So hopefully you guys can hear me well, and I'll start. And the people that are coming in now or joining can just catch up, I guess. So we're going to be um, having our last class today. A lot of you guys throughout the course were asking me when the last class would be, and I kind of evaded that question, partially because I don't think it's a good mentality of always thinking about the last class in general, but today is our last class, so we'll be summarizing mostly what we learned throughout all of our 12 classes. The first class was the introduction, and today the 12th class is our last class. So that means that we had 10 classes of full content. But before I begin our summary, I want to wrap up a bit of what I wasn't able to finish last class in regards to graphical user interface. And unfortunately, I wasn't able to get my my demo working during the last video, so I sort of fixed it, and now it should work. I'll open the project. So what I did in between the meetings was basically, for those of you guys that may have missed the last meeting, I tried to demonstrate making a graphical user interface and the benefits of doing so, along with the disadvantages by demonstrating how to create a calculator using the standard user interface that Java utilizes, and then following by giving a demonstration of what a simple basic addition calculator would look like using a graphical user interface. And I wasn't able to get it to work during the class, but I said it was no big deal because we have following class to resolve any problems and catch up on anything that we didn't get working last time. So I'll go over. Okay, so to reiterate what we did last time, I created a standard project laying out all the buttons and menu bars and labels using the graphical user interface editor, which you can start whenever you start a project. You can access it. It allows you to like sort of format everything, make it look pretty, and whatever. So, and all of that is on the pretext of having a graphical user interface extension, and that I posted on Google Classroom. So if you're interested in doing something like this by yourself, you have the resources to do so. And after creating it and laying it out on the graphical user interface editor, Java basically automatically compiles the code for each of these buttons and how to utilize it to make these buttons do something is we give each of them an action listener. So when the button is pressed, whatever is in the action listener is run. And as we can see here, we created a function, a method, for what happens when all of the numerical buttons is pressed, and also, let's see, a different method for when the addition or equal sign is pressed. So yeah, and the issue that I had earlier that I managed to solve via debugging was that before I had the action listener for button 11 instead of being the action listener for 11, it was for 10, and that made it so that the program didn't work because whenever I pressed button 11, nothing happened because I did not have the action listener for the button, and by fixing it, changing this from a 10 to 11, everything should work. And I also made it so that the code worked a little more ideally by writing this flag function. So when you're doing an addition problem, right, you want to know when the cutoff between like the A, like the first number, and B, the second number is. So what I did was, after pressing some number for the first number, you can press whatever number, and after you press the addition sign, I marked a Boolean flag, a variable that basically tells the computer if the first number has already been entered, and if it has, the flag is changed to true, and that's some different variable B. So, for example, if not flag, whatever button we press is set to a variable A, but if we press the addition sign, flag is changed to true. So after that, any button that we press becomes a variable B, and the result of adding these two variables is printed out in the label, which is another part of the graphical user interface. So this basically fixed any problems we had before with it not working. Does anyone have any questions about this? And I'll demonstrate to you guys that it works. So pretty simple. If we do, for example, what's the thing? I think I showed 5 plus 8 during the last video, I'm not sure, but I can do something like that. 5 plus 8, it just calculates for you. So this is a working calculator program, albeit obviously a pretty simple one with only an addition sign, but this utilizes what we call the graphical user interface, and anything beyond what I showed in this simple example project requires just like more coding in terms of what we deal with in regular Java, and like doesn't require anything else in terms of utilizing and knowing how to use a graphical user interface. So I guess this kind of wraps up what I started last meeting in regards to demonstrating how to use a graphical user interface. Does anyone have any questions about this? And I'll give like perhaps my last reminder. If you want to talk to me, ask me any questions, any comments, insult me maybe, just press the chat button and you can type messages to me. Oh, and while I'm waiting to see if anyone has any questions, I posted a survey on our Google Classroom for this class. So if any of you guys are interested in filling it out for the benefits of seeing if there's interest for another class like this or whatever, something else, feel free to do so. The link is posted on Google Classroom. There's only like 3 questions and it's a Google form. So yeah, that's my public service announcement for the day. So now that we wrap this up, I can give a sort of summary for what we went over. I think the form is blocked. Oh, okay, I'll fix that. Thanks for telling me. Wait, what does blocked mean? Like, do you guys not have access to it? says I need permission. Okay. Okay, thanks. I will change that. Yeah. Actually, let's see. Maybe I can change that right now. Actually, I'll change it after this class. So, yeah. Thanks for letting us know. So, I'm going to go over each of these 10 classes. And if you guys have any questions or concerns about any of these topics, now's the time to ask me. Feel free to do so. I don't have a lot else planned for today, but I'll start with our first class. Basically introduced conditional statements, which is if-else statements. So this allows the computer to check for something. For example, if we want to do like, I'll go back to the calculator example because that's on the top of my head, and for simplicity, for example, if we wanted to create a program that adds every number that the user inputs to 5, we'd do if, wait, no, that's not a good example. If we want to create a program that checked to see if everything that the user inputted was less than, say, a number 5, we would do, we have the user first input like a number, say, and we assign it to some variable a. Then we would do an if statement. If a is less than 5, then print some statement or whatever. And basically an else statement is if we have a bunch of conditions, the first one is always if. If we have multiple conditions, first one's if, and then there's an if else. If the first condition doesn't work, then it checks the second condition. And after a bunch of conditions, if you have one general case for everything else, it would fall under the else case. And usually in programming, the else statement usually processes like any like unexpected values. So it would return some -1 to show that it isn't there. For example, if we're checking to see if some string contains a character A, for example, and it does not exist in the string and there's no location for it, Java would output -1. So that's just an example of when an if-else statement would be used. On the second class, we talked about class design. And class design basically gave an overview for how Java works. We have multiple classes, and these classes can refer to each other. But for the sake of simplicity, most of the times we will be dealing with one class, and within these classes, we can have a main method, which is where we run everything, and we can also have separate methods underneath it. And as I mentioned earlier, I think the reason we want these methods is that it allows us to save time instead of having repetitive codes. If we have a method, we can call upon it, and that saves us time. And part of that class, I described the parts of a method construction, including the most important part, the method signature. And the method signature involves public, and then the return variable, which can be void if nothing is returned, the method name, and then the parameters, which is what the method may intake as a variable to use within the method. And if it has a method parameter, whenever we call upon it, we have to include certain variables or values for these parameters. On the third class, we talked about variable types and evaluating expressions. So I went over the various variable types in general. What we're going to be seeing most commonly is integer, which is an integer. Boolean, which is true and false. We did this for logical statements and if-else statements. if something evaluates to true, then everything within the brackets is run, and if it's false, it's not. Uh, and also double is anything that's not an integer if it has some decimal places after it. And also another variable type would be character and string. And then I also went over evaluating expressions, and part of this is knowing order of operations in regards to uh, integers, and also that Java, when you do a division where anything that results in a decimal place for integers, that Java will concatenate it. What that means is that it will get rid of everything after the decimal place, because if we're assigning a rational value to an integer, that's not allowed. So Java basically just takes out the decimal part. And also another part of evaluating expressions would be evaluating Boolean statements. And this is kind of like a logical statement thing. For example, if I do uh, if A is true or B is true, then that's the same as doing if A and B are both false. And that's uh, basically like knowing the logic behind how Java runs certain statements. And in this scenario, A and B can replace with whatever thing we're checking. For example, if A is equal to 5, or if B is greater than 8 or something like that, those are possible expressions that we could be checking for. On the fourth day, not the fourth day, fourth class, we went over strings. And the main important part of strings is to know that there are certain inherent methods that Java has for strings, and that because strings are not primitives, we can call upon these functions to use. For example, I mentioned the string.length method, which gives how many characters there are within, say, a string of characters or a phrase or whatever. And there are a bunch more. You can either refer to the video from that class, or as I always like to say, coding is a pretty open, there's a lot of open resources for coding. So feel free to search online for string methods, Java, something like that on Google, and you can always find the string method. On the fifth class, I went over loops, and there are two main loops, the for and while loops. For loop basically gives a iterative and standard way of running some segment of code n times, for example. As I usually do it, it would be for I equal to 0, comma, I less than some value n, comma, semicolon, I plus plus, and that would run the code within the for loop, say, n times. And the while loop is the loop runs infinitely until some condition is met. So while A is true, the code runs. If we go back to my calculator example, while the addition symbol has not been pressed, the first integer can still be updated. So does anyone have any questions on this? On the first 5 topics that we went over? It's sort of like a recap, I guess, and a great time to ask any questions if you're still confused about anything. In the meantime, I like to demonstrate that you can always find these resources simply by Googling. For example, I just Google Java string methods, and you get all these methods. And if you know how to, say, apply one method, applying all these methods is the same. It would be, for example, if you have some string A, it would be A that length, parenthesis, and that would be represent some variable with the whatever string is in question and the length of it. So yeah, as we can see, there are a lot of string methods. A lot of these we won't be using. And obviously I didn't have time to go over all of these, but I went over the few most important ones. And you can always see if there is a method for anything you want to do with a string by searching it up. So does anyone have any questions about that? All right, it seems like you guys understand this, which is great. I'll move on. I'll go over the content for our last 5 classes. On our 6th class, I talked about arrays, and part of this is 1D arrays and also multi-dimensional arrays, for example, 2D arrays. And arrays allows us to store a bunch of information and refer to individual variables on a systematic basis. In each array, an array index corresponds to some value, and instead of having a bunch of variables for everything, we can correspond an index to the value a variable in the array stores. So that's very useful. And if I recall correctly, after learning about arrays, I did a demonstration and also partially a project involving tic-tac-toe, in which the ideal solution involves storing the values, that is the X's and O's for each box within an array, because the tic-tac-toe board is a 3 by 3 array of squares, you can see, sort of. And it's a 2D array is a good representation of that. On the 7th class, I went over recursion, and partially that was because part of my solution for tic-tac-toe involved a recursive step. And basically what recursion is utilizing while loops to recurse and call upon a function over and over again until some condition is met. The most obvious recursive scenario would be if you want the user to input a valid value for something. For example, if you want the user to input a number between 0 and 100, you could tell them to input the number again and keep on doing that if the number is not within the correct boundaries. That would be what we call recursion. And there's also more numerical implementations of recursion. If you do math, for example, the factorial can be represented as a recursive function, because all the way until you reach 1, the function calls upon whatever is multiplied so far and then multiplied by recurse n minus 1. So that's sort of recursion as well. And also a key thing that I want to emphasize during the class was that anything that you can solve via recursion can be solved via iteration as well, which is for loops. So this is why for loops and while loops in general are interchangeable, but it's a good idea to know how to use both, because sometimes a recursive solution is much easier, while other times an iterative solution is much more easier. So having both in your toolbox is a valuable skill. On the 7th class, I went over output formatting. So as we know, I'll pull it up real quick. The standard Java user interface looks, oh shoot. Standard Java user interface looks something like this. This is what we refer to as the standard Java user interface, and it's a text-based interface, so the user can input some statement like to or some integer here, and based on that, the code can respond and output something, and also anything that the code outputs is directly outputted to this interface. For example, the default Hello World program outputs Hello World, supposedly. Might take a second. Yeah, so anything that the code outputs is outputted to the interface, and the user can type anything into here as well. But sometimes we want to format what is outputted, the text, into some way special. So this is where the different print functions will come into play. We talked about the printf function, and also the difference between the regular print function and the print line function, and also other tips and tricks you could do to format what is outputted. For example, /n \n is a new line function, and this extends beyond Java as well. For example, for people that know what LaTeX is, it's all about how to represent who you want to represent and display by using code. So that's output formatting. On the ninth class, I went over search algorithms. Now this was a very interesting class. I went over not only search algorithms, but also sorting functions. There are a lot of sorting functions, and if you're interested, you could search up some of the sorting functions I mentioned within the video on Google. But Java by itself automatically has a sort function that uses quicksort, and I demonstrated how that could be useful to sorting some, say for example, some array of elements you wanted to sort from least to greatest. You could use the Java sort function, and once you have something sorted, you can search for any element within the array using a binary search, and this speeds up the process by a lot than whatever searching would look like going through every single term in the array. So binary search is a very useful skill, and I went over that within that class mainly. On the 10th class, and part of this class as well, I went over graphical user interface, and the large part of this extends beyond using Java for creating an algorithm per se, and it's more useful if you want to create a game or some design or whatever you want to do outside of the normal interface that I mentioned in the output formatting class. And I demonstrated how using an extension for BlueJ or perhaps a similar extension for other IDEs, environments, Java environments, for example, Eclipse, you could accomplish the goal of creating something that the user can interact with easily. I mentioned how to add buttons to the environment, and also how to utilize whatever is added using what we call an action listener. So the action listener is really the only thing that's really new about a graphical user interface. Everything else basically just incorporates Java knowledge for the regular user interface. But adding an action listener, basically what it does is it's an if statement. It's an incorporated, self-incorporated if statement if the button is pressed, or if whatever happens within the graphical user interface. For example, other possibilities could be if you have a drop down list and the user changes the list from one to another, you could check for that. And if that happens, then some method is performed. And that allows the button to have a function. Going back to the calculator example, as I have many times. Oh, shoot. Is that JFrame I missed last time? Not exactly. JFrame in general is the entire graphical user interface. Everything else is a element within JFrame. So you would add buttons and text boxes and whatever to the JFrame, and after it has been added, then you can see its position or whatever on JFrame, but you don't need to really know all that because with the graphical user face extension, when you add basically dragging a button onto the frame of the user interface, Java creates all the code for each of these buttons for you, if that answers your question. And I'll go back to what I was saying earlier. In our calculator example, we have action listeners for each of these buttons. So when I press a button, the corresponding value is stored into a variable. And for example, I press 5. 5 is displayed within the text box at the top. We call it labeled. And there was another button that when we pressed allowed us to add numbers together. And both of those use what we call an action listener class. So hopefully that's enough to answer your question regarding JFrames. Does anyone have any other questions in regards to any of these 5 topics? I know that some of these are quite confusing, especially arrays and search algorithms. These are two very important topics that are quite difficult. So feel free to ask any questions that may still be confusing you at this moment. While I'm waiting to see if anyone has any questions, I'll just check to see what's wrong with my survey real quick. Feel free to ask any questions. Edit after submit. Save. So I think this fixes it. If anyone would like to try to see if it works now and tell me, so that would be helpful. Can someone do that? If not, you guys can always email me to let me know if there's any issues. Okay, it works. Thanks a lot. So yeah, one last reminder. I may sound like I'm repeating a lot of things. It's our last class. It's chill. Wait, so feel free to fill out the form to gauge interest for following class and to also like reflect on if you learned something or not and whatever. So it should work now as someone for our class confirmed. And that's all I have for today. I want to thank all of you guys, although I could have had more participation, but in general, I'm glad that hopefully you guys were able to learn something from all of these classes. We went over a lot of content. I know that all of this is very difficult, in that I went through all the topics of Java at a relatively fast pace. And as a result, I want to thank everyone that was able to take a little time out of their day each week to come to my Zoom classes. And even if you weren't able to come every class, I appreciate you guys watching the videos and trying to learn something. So this wraps up Introduction to Java Programming. Hopefully you guys don't think I talk too much or something like that. And this is all I have today. So thank you guys. And check Google Classroom for all the resources. I'll keep the classroom open so you guys can always view the videos from each of the classes in the course and the slides. And everything else is on YouTube as well. I'll be ending class with this. Thanks, guys. Bye.